Hey guys, welcome back. Day 2 of week 2, distance learning. All right, so today what we're going to work on is writing equations from graphs. So it's going to be a lot like writing our equations of a line from a graph, and we did that last semester. We did it a couple of ways. We used y equal mx plus b. If it's that convenient, then no worries. If I can find the slope and I can find the y-intercept, I can write any equality. And for us, all we're going to have to do is determine whether it's less than, greater than, less than or equal to, or greater than or equal to. The other way we wrote equations last semester was y minus y sub 1 equals m times x minus x sub 1, and we used a point that was on the line. So we can still do that, but in our case, we won't need to use point slope form, which is what this is. Here's our slope and here's the point. So the point that I'm talking about was x sub 1, y sub 1. We won't have to use this in this setting. The reason being is we have a y-intercept here, we have a y-intercept here, we have a y-intercept here. Okay, so here's what we are going to do. We are going to have steps, okay? And the steps that we are going to use is going to be first, it's either or, but I'm just going to say first, find the y-intercept, okay? It's the first thing I want to do. Identify y-intercept, 0b, okay? Second, identify slope. The slope of the line, rise over run. And remember, I like to spell rise with the y, because that reminds me that the y, the up and down goes on top, over run, okay? We'll just leave it at that. So we're going to find the y-intercept, then we're going to find the rise, and then third, we're going to write our equation y, leave a space, mx plus b, and what we're going to do is determine two things. Determine if it's dashed or solid, the line. Remember, dashed is a less than or a greater than. Solid is a less than or equal to or a greater than or equal to. And then, pardon me, fourth, we're going to determine shading. Is it going to be shaded above the line or below the line? And if you look at our graphs right here, this one's below, this one's above, this one's below, this one's above. So with that said, let's get started. First thing I want to look at, and this is not necessarily a fixed order, 1, 2, 3, 4. You're going to figure out that you can do them all in any order. But I'm going to look at this thing, and I'm going to highlight right there, I'm using a little bit of yellow, my y-intercept, and I'm going to count 1, 2, 3, 4, 5, 6. So b equals 6. Now, the next thing I'm going to do is I'm going to just look at my line, and I'm going to try and determine my y-intercept, or my slope. I see there's a point there, and there's a point there. So I can draw this triangle in for rise over run. I'm going to go down 2, and I'm going to count 1, 2, 3, 4, 5, right 5, and it's a plus 5. So I counted down 1, 2, and right 1, 2, 3, 4, 5. So that's my slope. So now I know that I have a slope of -2/5 and a y-intercept of 6. And then I look at the line and I'm going to say it's solid. because it is. It's a solid line. So that means it's either going to be a less than or equal to or a greater than or equal to. So I'm going to write y. I'm going to leave an opening. Negative 2/5 x plus 6. So if it were just a line, it would be an equals. But I have to decide, is it greater than or less than? Now, if you recall from a couple days ago, my favorite number to use, and I'm going to try pink. I don't know if it's going to show up for you, but I'm going to pick that number right there that I just made a big circle around. I'm going to use 0.00. So 0.00. So this is x and this is y. Now, what I'm going to do is I'm going to plug in a 0 here. Negative 2/5 times 0 plus 6. So 0 and 6. Is 0 less than or greater than 6? It's less than, so it's less than or equal to, which means this gets a less than or equal to. Okay? So it's shaded below and it's less than or equal to. That is our first equation. All right? Let's go over to the next one. And I'm just going to use my red pen and I'm going to circle this point. And I'm going to count down 2. So my B equals, my B equals B equals, kind of messed up. I started to write two things at the same time. B equals negative 2, so my y-intercept is 0, negative 2. My slope. So when I'm looking at this line, I'm looking for where it crosses through a clean point, a clean intersection point. So I can see it's going through that point right there. I'm going to count up 1, 2, 3. So it's up 3. And I'm going to count 1, 2, 3. So it's right 3, which means it was up 1 and over 1, up 1 and over 1. I just have old eyes. If this were up on the whiteboard for me and a lot bigger, I would have seen it sooner, which means my slope is 1. Okay? So we know, and it's dashed. Let me make that point. It's dashed, which means it's either going to be less than or greater than. So y, leave a space. Slope is 1, so it's x minus 2. What point do you think I want to use? If you said 0, 0, you are correct. So I'm going to plug in y equals 0 and an x equals 0. So it's going to be 0, negative 2. Is 0 less than negative 2 or greater than negative 2? Greater than negative 2, right? So I'm going to make this one greater than. Greater than, okay? Now, notice it's shaded above the line and it's greater than. It's shaded below the line and it's less than. I don't care about the equals. The shading has to do with the less than, greater than. So since this is less than, it's shaded below. Since this is greater than, it's shaded above. Why am I making a deal out of this? Well, big deal. Here's the reason. We're testing points. But if you write your inequality with y on the left and everything on the right, then this inequality goes with the picture. Okay? It's shaded below the line, it's less than or equal to. It's shaded above the line, it's greater than or equal to. In this case, it's greater than because it's dashed. In this case, it's less than or equal to because it's solid. Okay? So, a couple of key points for you, because I'm going to kind of throw you to the wolves right here, okay? What I mean by that is I want you to pause the video and I want you to do C and D on your own. So pause the video right now and go do exactly what we did for A and B, for C and D. When you are done, turn on the video and watch me to see if your work matches mine. Talk to you in a few moments. Okay, so my y-intercept is 1, 2, negative 3. So b equal negative 3. My slope is up 1 and right 2. My slope is up 1 and right 2. So my slope is equal to 1/2. It's dashed, so it's either a less than or a greater than. So y, leave space open, is 1/2 x minus 3. It's below and it's dashed. I'm going to say that it is less than, and then I can go test my point. Test. I'm going to use 0, 0 again. I like using 0, 0. And if you haven't figured out why yet, then pay attention. If I plug in a 0 for y, I get 0. Is less than, I'm going to put a little question mark right here because I'm testing it. 1/2 times 0 minus 3. Is 0 less than negative 3? No, it's not. So this is correct. Okay, so if I pick 0, 0 to test it, and 0, 0 is not in the solution area, then I better get a false statement, and this is false. 0 is not less than negative 3, it's positive, or it's greater than. Okay, so this looks like a slope of 1, a slope of 1, a slope of 1. So my slope equals plus 1. My b equals negative 1, and it's solid. And it's above. I'm going to just take a shot in the dark here and say it's going to be greater than or equal to. So my equation is going to be y is greater than or equal to x minus 1. I'm going to test it with 0, 0. Is 0 greater than or equal to 0 minus 1? Is 0 greater than or equal to negative 1? That's true. Guess what? We are done. If I made that look easy, if you understand the concept, it isn't that difficult. Stop the tape. Stop the video. Do E and F. After you do E and F, come back and look at my work. If your work matches my work, guess what? You're ready for the homework. All right, see you in a minute. Got a frog in my throat this morning. Okay, so my y-intercept is negative 1. This is a horizontal line. Do we remember? The question is it a y equals or is it an x equals? And if you have forgotten, here's what I'm going to do to try to refresh your memory. I'm going to pick points. I'm going to pick this point. Negative 3, negative 1. Okay? I'm going to pick this point. Negative 2, negative 1. I'm going to pick this point. Negative 1, negative 1. 0, negative 1. 1, negative 1. So on. What never changes is y. So guess what this is? Y equals negative 1. It would be, except that it's not an inequality, so this isn't our answer. The question becomes, is it above a line or below? But I'm going to first deal with dashed. Okay, it's dashed, so it's either going to be a less than or a greater than, and it's above the line, so I'm going to take a shot at greater than, which means I'm going to write my inequality as y is greater than negative 1, and then I'm going to test it. Test. Okay, I'm going to use 0, 0. Well, there is no x to plug in, so I just plug in 0 for y, and I ask myself, is 0 greater than negative 1? That's true. Hey, guess what? That is our inequality right there. And it's dashed, so it's not equal to. Okay, so since this was the y equals, this must be the x equals. So this is going to be x equals, and we just count. 1, 2, 3, 4, 5, 6, 7. Okay, so x equals 7 is this vertical line right here. It is solid. So it's either going to be less than or equal to, greater than or equal to. So over on the two equations, or the four equations that we did before, we looked for below or above. On y equals, we're going to look below or above. This is going to be the greater than. This is going to be the less than area. So on an x equals, what do you think? Think about the x-axis. As we go to the right, numbers get bigger. As they get bigger to the right, they're positive. As they get smaller, they're negative. Well, so what I'm trying to get you to see is that this is going to be x and 7, but it's going to be less than. Now let's test it. Test. Okay, we're going to use 0, 0. So is 0 less than 7 true or false? It's true. So on an x inequality, if it's to the left, it's less than or equal to. If it's to the right, it's greater than or equal to. And there endeth the lesson, second lesson of the week. Talk to y'all later.